Alright, good morning everyone. Welcome back to our second video for chapter 2 revision. So now we are moving on to the physical quantities, physical properties of different materials. So how do we describe materials like plastic, glass, metal around us? One good way is to look at their physical properties. And shown here are a few physical properties. So we'll go through them quickly. They can also be found in your textbook, but let's go through the definition of each physical quantity in greater detail in case you have forgotten. Remember, this is chapter 2 of your textbook. Firstly, we have hardness. Now, hardness is the ability of a material to withstand scratches by another material. So hardness is about scratching. So the idea behind this is a harder material can scratch a softer material. So if a material has a higher hardness, harder, it can scratch a softer material. However, the other way around will not work. A softer material cannot scratch a harder material. Okay? So if a material is known to be softer, lower in hardness, it will not be able to scratch something else which is harder than itself. So hardness can be defined and measured on what we call the Mohs hardness scale. Now the Mohs hardness scale was originally planned and designed to measure the hardness of different minerals, gemstones like diamonds, sapphires, amethysts. These are gemstones. But what you can see is diamond is the hardest material. Diamond is assigned a hardness of 10 on the Mohs scale. This means that diamond is the hardest material. And therefore, diamond will be able to scratch materials that are softer than itself. Meaning, diamond can scratch sapphire. Diamond can also scratch fingernails, steel, knives, glass. Alright, so diamond being the hardest material can scratch other materials that are lower than itself in hardness. On the other hand, can steel scratch diamond? So steel, the hardness is at 6.5. So you can see, compared to diamond, which has a hardness value of 10, steel has a lower hardness, meaning steel is softer than diamond. And therefore, steel cannot scratch diamond. It cannot scratch diamond because steel is softer than diamond. Okay? Now, hardness is about the ability of a material to withstand scratches. So a harder material, like diamond, cannot be scratched. Itself. It cannot be itself scratched. So diamond is not scratched, but it can scratch others. Okay, so this is an important concept to get. Now, besides the idea of scratching, hardness also has to do with cutting. Because diamond is so hard, diamond is a good cutting tool. We often think of cutting tools as knives which are made of steel. Steel is pretty hard. It has a value of 6.5 on the Mohs hardness scale. But the best cutting tools are actually made out of diamond. Because diamond is able to not just cut through normal plastics, fibers. Diamond is also able to cut through things like metals. Diamond can also cut through things like gemstones like sapphire. If you wanted to cut sapphire, you will need to use a harder material than sapphire. If you look, sapphire has a value of 9 on the hardness scale, which is to say, probably only diamond, which has a higher hardness value of 10, will be able to cut sapphire. Okay? So this is the idea of hardness, the ability to withstand scratches, and this impacts affects how this material behaves like a cutting tool. So the next concept is the concept of strength. The strength of a material is the ability of the material to withstand or carry heavy loads without breaking. So now is the idea of putting heavy stuff on top of the material and measuring if the material will break. So we basically load the material with heavy stuff until it breaks. And that is the point by which we say it has reached its maximum strength. Okay? Now you can see these are the tensile strengths of different materials like skin, rubber, crystal, ceramics, brass, steel, and shockingly, spider web. Now you can see that spider webs are actually surprisingly strong, especially when you compare it with something like steel. Steel is 620, spider web is 600. So spider webs are not too far away from the strength of steel. This shows you that spider webs are actually really strong. What that means is that it could withstand heavy loads that are much heavier than itself without breaking. And that's why spider webs are one of the materials that actually material scientists, researchers who look at materials, are very interested to learn about. Because spider web could inspire a lot of future material research. We can make new materials that are as strong by looking at the structure, the composition inside a spider web. Okay? So this is the idea of strength, the ability to withstand heavy loads without breaking. Now we move to the concepts of flexibility and malleability. Now these two concepts are rather similar, flexibility and malleability. Now flexibility is really the ability to bend into different shapes without breaking. Malleability is the ability of the material to be molded into different shapes without breaking. So malleability starts with M, molded also starts with M. So the idea behind flexibility and malleability is to look at whether the solid, the material, could be changed into a different shape easily without breaking it. Now, not all materials are flexible. So some materials are particularly flexible. For instance, some plastics are very, very flexible. A good example is the plastic bag which you use to contain your groceries or items whenever you go shopping. The plastic bags have to be flexible. If they are not flexible, they cannot be bent, okay, into different shapes, like the shape of the plastic bag without breaking. Okay, so plastics are quite flexible. The next properties have to do with change of state. So melting point and boiling point. Melting is to change from solid to liquid state. Boiling is to change from liquid to the gaseous state. Alright, so melting point is the temperature at which the material changes from solid to liquid. Boiling point is the temperature at which the material changes from liquid to gaseous state. Okay, so remember, melting points and boiling points are temperatures. So the answer for melting and boiling point must be in temperature with the unit for temperature. The common unit for temperature is degrees Celsius. But remember, degrees Celsius is not the SI unit. The SI unit is Kelvin. Okay? For temperature, the SI unit is Kelvin. And now we move on to the last properties. Electrical conductivity is the ability of the material to carry electrical charge freely. Thermal conductivity has to do with heat. Thermal and heat are closely related terms. So thermal or heat conductivity is the ability of a material to transfer thermal energy or heat energy from one point to another point. And finally, we have density. Now, density is defined as the mass per unit volume of a substance. Whenever you read this word per unit, what it means is this. Density is mass divided by volume. So per unit literally means divide by. So mass per unit volume means mass divide by volume. Now density is important because density allows you to work out if the substance will sink or float. So for instance, steel would sink in water. It sinks in water because it has a higher density than water. On the other hand, wood floats on water. Wood floats because wood has a lower density than water. So the concept of sinking and floating in a particular material is related to the density of the materials. Okay? And remember, the formula for density is mass over volume. Okay? Now, the formula is important because you have to be able to do calculations based on the formula. Whenever you learn a formula, always learn it with the units. Mass can be in grams, so grams per cm cube, since it's mass over volume. Now, but more commonly, the SI unit is kg per meter cube. Remember, the SI unit for mass is kilograms. So therefore, the SI unit for density is kilograms per meters cube. Now, which unit you use depends on, of course, which units are you given in a question. So if the question provides you the units in grams and cm cube, then just use grams and cm cube. And therefore, your answer for density will be in grams per cm cube. If a question gives you grams and cm cube, just stick to it. But I'm trying to highlight here, the SI units for density is actually kilograms per meters cube. Okay? So these are the common physical properties of a material which you need to know. This can also be found inside your OneNote notebook under Chapter 2 Revision Notes for EYE. And lastly, we learned there are different materials around us. We have ceramics, metals, glass. These are common materials around us. This is taken from your textbook for Chapter 2. Now, ceramics are basically clay. Ceramic is basically clay. Now, ceramics are poor conductors of electricity. They are hard, meaning they are not easily scratched. They can withstand scratches. But ceramics could scratch other materials which are softer. Ceramics can be molded into different shapes. It doesn't corrode. Another word for corrode is rust. Now, ceramics also have a high melting point, which is good because ceramics can withstand high temperatures. When you have a high melting point, what it means is that you remain as a solid even at a high temperature. So this could be a useful property for a material to put into the oven, to put into a furnace where there's a very roaring fire and the material for the furnace must actually withstand the high temperature. So anything that needs to withstand high temperature, we will actually use something with a high melting point like ceramic. Now, ceramics are fragile. Fragile means it breaks easily. So I'm sure you have encountered this before. Your flower pots are made of ceramics. Flower pots made of ceramic are easily broken if you drop them. Okay, so that means ceramic are fragile. Then we have metals. Metals are common materials, you should know this. Metals are shiny, they are good conductors of electricity, good conductors of heat. And that's why metals are commonly used to make electrical wires. They are good conductors of electricity. Metals are also commonly used to make the base of pots and pans because they are good conductors of heat. Metals can be molded into different shapes without breaking. They can be bent without breaking as well. Okay, so that means metals are flexible and malleable. Next, we have glass. Glass is transparent, it's a poor conductor of electricity and heat. Okay, glass has a high melting point as well. And glass, of course, is fragile, it's easily broken. Now, glass is transparent. This could be very, very useful for making objects where you need to see through the object. So for instance, your test tubes are made of glass. Your test tubes are made of glass because of two reasons. Number one, transparent. It allows you to see the chemicals inside the test tube. while the reaction is ongoing. The second reason why glass is good for making test tubes is because glass has a high melting point. It can withstand high temperatures. Very often, we actually heat up our chemicals in a test tube. So the test tube itself must be made of a material that can withstand the high temperature, and therefore glass is a good option. And then we have plastic. Now plastic is very lightweight, it doesn't corrode. Plastic, as mentioned just now, can be molded into different shapes, can be bent into different shapes as well. So plastics are flexible, okay? Now plastic has a low melting point, and that's why it's very important to recognize that you cannot be heating up food, especially in plastic with a low melting point. Of course, now with modern research, there are some plastics that can withstand higher temperatures. But in general, most plastics cannot withstand high temperature. Okay? Now, plastic is also a poor conductor of electricity and poor conductor of heat. And that's why plastic is commonly used to make the insulation around the wires. Okay? We do not use plastic to make wires. We use plastic to make the insulation layer around the wire, so that in case you accidentally touch the wire, you are not touching the metal wire. You are touching the plastic insulation, which prevents you from getting electric shock. Now, finally, we have fibers. Fibers are commonly used to make clothes. Why commonly used to make clothes? Because fibers can be spun into threads and woven into fabric. Alright, it can absorb the dyes, so it allows you to make clothes which are colored. And of course, fibers are poor conductors of electricity and heat as well. Now, this is from your textbook, so I expect you to be revising your textbook alongside your notes and worksheets from semester 1. So this really brings us to the end of chapter 2 revision. If you have missed our first video on measurements and SI units, please go back to our first video to watch it. Please also review this video, which is on physical properties of your materials like hardness, strength, flexibility, melting point, boiling point, and so on. Alright, so I hope this video has been useful for you. Please do review this video as well as the other videos in the lower sec playlist in preparation for your end of year exam. Thank you.